Okay, so here's the 23. So I think this was number 19 on the 12B as well. So rectangular grid of the squares has a 144, like 141 rows and 91 columns. Okay. And each square has a room for two numbers. So, and two people, I'm going to call them H and V. Each fills the grid by putting the numbers 1 through 12,801 into the square. And then that's the both people. But the H fills the grid horizontally, and he puts the 1 through 91 in the first row, and then 92 through a 182 in the second row, and then that way. But at the same time, Vera does the vertically, and then 1 through 141 in the top to bottom in the column 1, and then next is like 142 to 282 in the column 2, and then etc. So how many of these squares will have the same number? Like the story is like this, if I want to make somehow visual. So let's say this is my first row, and then I'm going to say, let's say this is my first column. So like we start with like one number, like say this is 1, 2, 3, 4, and then we just do this like 91 columns. So we're going to have this is like 91, and then we do have the second person is going to be 1, 2, 3, 4, all the way to the 141 like rows. So we have the 141 rows, but at the same time we have 91 columns. And then each square, so like when you complete this way, that will be like 1, 2, and then this will be like 141, this will be 142, 143, and stuff like that. So that's the whole story. But we want to see how many of the numbers are actually going to be in the same square, which like this one. So because both ones are in the first place. So what we can do, like we can just label the I'm going to say like H, which is like the person or race, right? So then it will be just the numbers that is going to be put in this way. So imagine like on the first row, first row, you continue with 1 all the way to the 91, right? So I'm going to call this like the row 1, 2, 3 all the way. But when you get to the second row, you multiply the like 92, 93, 94. So you just add 91 plus 1, 2, 3, 4, something like that, which is like column number. So meaning that we can just say HROC, meaning that the row and column can be written as like one lesser row number times 91. So plus C. What does that mean? Like if the R is, let's say, 1, which means the first row, then this will be gone, and then you get the column number. So when the first column is 1, second column is 2, third column is 3, fourth column is 4. This C is just the column number until we get 91. But when you get the second row, then R is 2. That means it's going to be 91 plus C, 91 plus 1, which is going to be 92. 91 plus 2 is 90, like 91 plus 2 is 93 and stuff like that. So that's the general expression we can write for the horizontally. And similarly for V, I can write R of C is going to be like the similar to this one. So we are going to say C minus 1 times 141, and then plus R. Okay, so then we just want one of like these two numbers to be same, so then we can make them equal to each other. So before you move on, make sure you really understand this one, otherwise the rest will be not really useful. So we want these numbers to be equal to each other. So let's expand those. So you got 91R minus 91 plus C is equal to 141C minus 141 plus R. And I can pull the maybe 91, like I can subtract 1C from both sides. So you got 140C. And then I can subtract 1R from both sides. So you got 90R. And I can add 141 to both sides. So you will get, this is like 9 lesser than 100. So if I take the 41 plus 9, which looks like 50, and is equal to 0. So I can divide by 10. So you got 9R plus 5 is equal to 14C. Okay, so that is something. But right now we do have some relation between the R and C. Maybe we can take the mod something to get rid of at least one of these variables. Looks like easier to do mod 9. So if I take mod 9, so that will be just 0 plus 5 is congruent to this is like 5 more than 9. So which is why that should be 5 times C mod 5. Mod 9. So like it looks like C is just 1. So C is congruent to 1 mod 9. So then what does that mean? Like C has to be the number of like columns, which has to be at most 91. So then you can just say C is 1 plus 9 times some integer. So then 1 plus 9K has to be at most 91. So that's my C. Then if I want to take this C and plug maybe into this equation, we can get something for R as well. So let's do that actually. So then I'm going to get the 9R plus 5 is equal to 14C. So 14 times 1 plus 9K. And you get like 9R plus 5 is like 14 plus 9 times 10, 98. So 9 times 4, 36, which is going to be 126K. Okay, so we got that one. But what do we do now? So maybe we also can take the like mod, like maybe we can try simplify first, right? So this looks like this will be all 9. So 9R is equal to like subtract 5 from both sides. So you got 9 plus 126K. Let's divide by 9. So you get 1 plus, this is like 12 divided by 9 is 1. So you got 36, which looks like 4. So 14K plus 1. Okay, so the R is the rows, like we have 141 rows. So the question is basically, we are looking for R comma C's to be the same number. So 1 plus 14K is my R, and then C is 1 plus 9K. So we can just plug things in. So if I choose K is 0, then you get 1 comma 1, which is kind of obviously the first one. And if I want to choose, let's say, like 1, so you got 14 plus 1 is 15. And then you got 10, so that should be another one. So you can just list these if you want to, just to count how many you can. But at the same time, we have a limit for those both ends, right? So if I want to choose, let's say 10 for the K, that will be 141. So 141, and then that should be 91. And then if you remember this is basically our RC, right? So the C is the column, the number of columns is 91 at most, which means 91 is the last number. And then luckily 141 is the row, is the last one as well. So we got this one when you choose 0. We got this one when you choose 10, which means we actually plug K as 0 through 10. So it looks like we have 11 actually numbers that does work. So that was an interesting question, to be honest, but I will say this is one of the, I guess, question that is kind of nicer because it is really require a bit much thinking. Anyway, I'll see next question.